the GEMS code has a 3-dimensional variable here, supply. These, the devices, S the seasons, T the time periods over the day. So those are 3 different boilers, and they can have a different supply for each combination of the season and the time period. In the GDX file, this looks like this. Boiler 1 is not in use. Boiler 2 is in use basically all the time. And boiler 3 only supports in winter, in the night, morning and evening, but not in the noon. We can, as always, use this very small script and load the data. And then we get a long list that includes all the values in here. Starts with 56.2, that's here, and ends with the 13.3, that's here, and all the other values are in between. Quite often I'm interested in just this part, or only this part, like the values for one specified set element. And this is what function 3 is, function read 3 for read 3-dimensional variables is for. So in this function I can, for example, specify I want read GEMS optimization, GEMS to Matlab GDX file, which is this, and I'm interested in the supply variable, which is here. And I don't want to see all the data, I want to make a selection. And my selection should be, for example, boiler 3. I'll type it here. And the function requires me to specify from which set my selection is done. So as boiler 3 is part of set D for devices, I type D here. And then I have to choose, do I want the seasons in the rows and the day periods, the time periods in the columns, or the other way around. I'll just do it like here, so that there will be seasons in the rows, time periods in the columns. And last but not least, I have to specify where MATLAB can find the data in this long result list. The unique element label order numbers for the set devices can be found in column 1. That's why here is a 1. And the unique element label order numbers for the set of seasons can be found in column 2. Same for time periods. And if I now run the function, it shows me the 3 values from boiler 3, plus all the zeros that also appear in this result. And I could easily change it to boiler 2 to get all these values. I can also, in this case it would not be interesting, but it's possible to specify I want to see results only for autumn, so that comes from the set seasons, and I want to have the time periods in the rows and devices in the columns. And then we need a new, then the values are in different columns now from left to right. So seasons is now in column 2, the time periods in column 3, and the devices in column 1. And then it looks like this. We could try to generate this here in the GDX file. That would be, we select autumn and put the time periods in the rows and the devices in the columns, and then would just look like this, plus all the zeros that the GDX file does not show. So here you can imagine boiler 3, and here just to the left of boiler 1 there's boiler, to the left of boiler 2 is boiler 1, and they don't supply in autumn at any time period, so they have zeros here, and these zeros are shown here. The function works really just like the function for a two-dimensional variable. There's just one more if condition in here, which leads to a certain value will only be put in the result matrix if the unique element label order number equals the selection set element, the unique element label order number from the selection set element. Yeah. And just as an example, how to also apply that, when, for example, we could make a small script and write the results into different matrices. And could then make a surface plot from matrix and in a new window from the other matrix. And the selected element should be different to make it more interesting. And then there is figure 1, a surface plot for boiler 2, and figure 2, a surface plot for